Hello, I am Bharath BL. Now I am explaining about the crowd detection system. So we are using YOLO V8 and OpenSea for the crowd detection. So basically OpenSea processes the images frame by frame which is sent to YOLO V8 which then detect the crowd using the yellow line. So now I am showing the software. So this is the main dashboard regarding the crowd detection system. So basically YOLO V8 it is an YOLO V8 it is a machine learning computer vision model. So now we are taking ESP32 cam, phone cam and a laptop camera. So basically phone cam is connected to the IP cam. Now I'll first show about the laptop cam. So it's starting. So you can clearly see it has started. So this is our software. So it is basically checking how many people are there, if the crowd detection is low or high, and it also detects the objects too. See, now it's detecting even this cell phone also. So if any person goes outside the frame, the crowd also gets updated. Now it's updated to 1. Now it's updated at 2. So we are using it in the bus cameras so that we can check the crowd detection and even in the stop, so that we can prevent accidents or collisions. Also we can check how much crowd is there in the bus, and we can update it to our software, and we can provide to our user if the bus is free to use or not. So now we will connect it to the cam of our phone. Ready?
Mobile on ಮಾಡಿ.
So first I will so now now it's connected to our phone. So we can see the camera is connected to the phone, and it's even detecting the objects and the people too. So basically the phone camera is very slow. Yeah, and the same thing is updated in our software too. And we have also implemented the chatbot in the software for any confusion about the software. So now I'll show about the database we are using. So we are using MySQL database. So these are the 3 tables we have created. And yeah, so basically it's running the values again and again, and it is sent to our main software. So it will detect the amount of people, and it is shown a software if the bus is loaded or unloaded, so that for the user's convenience. So thank you, and even we are using GPS location for it.
Hi, I am Dhanush. I am the team member of this project. The project is about smart bus traffic management and crowd detection system. This part is an hardware, and I am going to explain about this. This is a passenger counting device. Actually, we are going to collect the data from the buses about the passenger and the crowd in the bus stop. I am going to explain about only the part of passenger counting and the hardware part. First, we are using the microcontroller ESP8266 and sensors, IR sensors. This is the code. Basically we are planning. Basically this device will placed in the doors of the bus. Actually it will count the passenger in and out, like exit and entry. If the passenger moves from this one direction, it will show the passenger count. If we move in opposite direction, it will decrease. Means exit and entry. Like this part is basically a Blink software which collects the data from Wi-Fi through the microcontrollers. It will update the values through Wi-Fi, and also it will send wherever we want, like dashboard or anywhere else through Wi-Fi. Like if we move from one direction, it will count 1, and if it move again, 2, and if you move opposite, it will count or decreases. Basically, we are using permutation combination for this code, and we are using 4 sensors because it will improve the accuracy, and we are using AR sensors because it is cheap and it is easily available, and it is lightweight.
Hello everyone, I am Dev Kirti. Welcome to the software demonstration of this project. As we can see, all the information has been displayed on the top. We are recording this at 7:20 p.m. So let us start with giving basic information. The area which we are doing this is from Kengeri, and let us say we have to go to Kempegowda bus station. And this will be the bus stop which we are in, will be RV College of Engineering. So as we check the drop down menu, all the stops which are present in this route will come up, and yeah, there is RV College. So the map shows exactly which bus is coming next, what is the route, and what is the stop you selected. Now if we check for the stop, in the map it will directly pinpoint where the stop will be. Yes, as you can see here, it is pinpointing the exact stop and the location. And another button is to show the route of the bus present. So this is the route which the Google Maps has given from Mysore Road to Kempegowda bus station. And the map, on the left side of the map is the selected route buses, where it shows how many people are there in each route bus. This is dynamically calculated currently. And then is our novelty, the AI route advisor. If you put the from and to and tell advise route, it will check for the route and also check for the buses which would be the most efficient for you. So as you can see, it has shown avoid TR4 then 111 if you have to get time because it's crowded. On the left, on the other side, you can clearly see all the buses which are coming up next. Now this is the bus stop live board which shows exactly the passenger trend and how many people are coming. And then here it shows how many people are already present in the bus. And finally at the very bottom is a dashboard of all the buses which are currently working. Finally, we have the Google Maps API key. Once we get the API key, which costs, we can also put it here, because of which the maps and the entire system will automatically start working. So now let us head into the operator dashboard of this, because only the passenger cannot be expected to clear out everything. Again, this is a very similar dashboard to that of the passenger because a lot of requirements remain the same here. On the other side, on one side you can look at the map, and on the other side you can look at the upcoming buses, how many people are there in which bus and what exactly is it going towards. This is our operator dashboard. As you can see, you can easily scroll in and scroll out of the map to pinpoint exact locations. Then comes our dynamic ML model, which is currently predicting where more buses are required and where buses have to be removed exactly because of update in the bus strategy system. Then shows the route pressure, where the highest ones will require more attention currently. And this is the fleet monitor, which is a live dashboard of all the buses which are present in service right now. We also have a download Excel CSV file option, where you can easily download the Excel sheet and it can be used for later purposes. As you can all see, the action also is mentioned in this scenario. In the Excel sheet, when you open, all the information of the buses are present, which can be used to develop a grievance feedback loop system where grievances can be taken up. And this is the GitHub profile from where we have sourced the information to make this model. Thank you.